Hello, Mr. Bainey here. This lesson is 2.3, solving for a variable. The essential question for this lesson is how do you rewrite formulas and literal equations? The Common Core standard is ACED.4, rearrange formulas using the same reasoning as in solving an equation. So we're going to be using the same process as just solving a regular equation with one variable, and we're applying it to something that's going to have more than one variable. So first, I want to direct your attention to the vocab word phrase, I guess, here, literal equations. It's going to be an equation that contains two or more variables. And with that, we're able to move things around as long as we're using the properties of equality. Okay, that's the important thing here. So we're still using the same stuff, but it's just we cannot combine a lot of the numbers because we've got so many variables floating around. Okay, so let's see what that actually looks like. Let's go on to the next page. So our first type of example here. First, look at the top. The formula for density is D equals M divided by V. Looks like M is the mass and V is the volume. It tells you there at the end of the sentence. Okay, lead has a very high density of 11,340 kilograms per cubic meter, and plastic foam has a very low density of 75 kilograms per cubic meter. Okay, so that's going to be important information for us from when we do this example B here at the bottom. So I might have to scroll back up in a moment. Part B, the design for a life preserver requires 0.3 kilograms of plastic foam to provide proper buoyancy. What's the volume of the plastic foam required? So we're going to use the formula that was given to us for density, and it is density. Let's fill in the blank here. Density is equal to the mass divided by the volume. Okay, so what we want to do is we're going to get V right here, excuse me. We're going to get V by itself. We want to get that by itself. Okay. In fact, you know what I'm going to do is just rewrite it over here. And I want to show it to you just a little bit differently so that the fill in the blanks don't confuse you. So I need to get V by itself. Now it's in the denominator, this fraction, which I don't really like, so I'm going to get rid of it, get it out of the denominator by multiplying both sides by V. It's the same thing as multiplying by V over 1, right? V is the same as V over 1. So what that does is, on the right side, these V's actually become a 1, and it goes away. So I'm going to get VD, or dV, it shows it on the left side if you look at that, equals M. Now it looks a little bit nicer, at least, and easier for me to get the V by itself. Well, think about what the V is doing. It is multiplying with the D, right? It's right next to it, so it's multiplying. And since it's multiplying, we're going to want to divide the D, because I want to get V by itself, so I'm getting rid of the other variable. So that means divide this other side by D, and I end up with V equals M over D. Or using the units, right, or using what this represents, volume equals mass divided by density. So now I need to answer this question. So I did all that work just so I can answer this. What is the volume of the plastic foam required? Okay, the volume is what I'm trying to figure out. So in order to find the volume, okay, I'm looking back at my formula down here, I want to know what the volume is, so that means I need to know the mass and I need to know the density. Okay? Well, the mass is kilograms. It tells me actually up here, 0.3. So I'm going to fill in the blank for that. Here on the left side, volume equals 0.3 kilograms. And I'm dividing it by the density. Well, the density, remember way up here, it gave you the density of plastic foam. Okay, density is kind of like how filled up it is inside of it. And so, whoops, plastic foam has a low density of 75 kilograms per cubic meter. So 75. We'll take 0.3 divided by 75 kilograms per cubic meter. And that's going to give us our volume in cubic meters. I'll let you punch that into your calculator, do 0.3 divided by 75, and you will get your solution for that. Okay, go ahead and try the your turn. If you'd like to keep listening, and then I'll tell you when to pause it before I start writing in the solution. For altitudes up to 36,000 feet, the relationship between ground temperature and atmospheric temperature can be described by the formula T equals negative 0.0035 A plus G, in which T is the atmospheric temperature in degrees Fahrenheit, A is the altitude is the same as height, in feet, at which the atmospheric temperature is measured, and G is the ground temperature in degrees Fahrenheit. Determine the altitude in feet when T is negative 27.5 degrees Fahrenheit and G is 60 degrees Fahrenheit. All right, a load of information there, but we have this formula. They already gave this to us. T, we have the variables T, A, and G. And it says it wants us to determine the altitude. Well, the altitude is A. So what I'm going to ask you to do, you can pause it to give it a try, is to take this formula and get A by itself. After that, you will plug in or substitute in that for T and then 60 for G. Okay. Here we go. T equals negative 0.0035 A plus G. First step is I'm going to subtract G on both sides. When I subtract T on both sides, it's going to be T minus G, right? I can't combine those, not like terms, equals negative 0.0035 A. Then, last step, get A by itself, or we have to divide. Okay, we're dividing this thing on both sides. When I divide on the right side, I just have A, so that's easy. So A is going to equal this T minus G, all divided by negative 0.0035. Okay. So then when I take this, let's box it, it tells me that, take a look at my arrow, I got T is equal to negative 27.5. So negative 27.5 goes into here. G is 60, so 60 is going to go in here. And that's going to be my solution once I work that all out. So it's going to be negative 27.5 minus 60. That will definitely give me a negative number. Divided by negative 0.0035. And since we're dividing by a negative, that's going to become positive. That's a good thing because A, remember, is my altitude. And that's the height. So it needs to be a positive number. But anyways, I'm not going to calculate this. I don't have a calculator available, so you can go ahead and put that into a calculator to figure out the altitude. And just make sure that you express that in the correct units, which is feet. Go on to the next page. And let's just go directly to the your turn, because all it's having you do is rearrange this formula. Your turn number 3, the formula y equals mx plus b is the slope-intercept form of the equation of a line. Solve the equation for m. If you'd like to go and give that a try, pause it before you see the solution I'm about to write down. Okay, y equals mx plus b. I want to get m by itself. So the first thing I'm going to do is subtract b on both sides. I'm going to use the subtraction property of equality. So subtract b, which means I'm going to have y minus b on the left side, and that plus b is going to be gone, so I have just mx. The last step is to get, in order to get m by itself, we're dividing by x, which means on the other side I'm also going to divide by x, and I end up with m equals, I flip-flop them around, m equals y minus b all divided by x. And there's your solution. That's going to be it for this lesson. Thank you for watching. Have a good day.